Okay, good morning, afternoon, or evening, everybody. This is your host, Jennifer Brennan, and I'd like to welcome all of you to today's NASA Earthdata webinar. You have joined the Goodbye FTP, New Ways to Access NASA's Physical Oceanography Data at PODAAC webinar. While everybody's logging in here, we do have two optional polls, and you'll find those located at the bottom left and middle portion of your page. And I'd like to thank all of you in advance for your participation and your feedback on these polls. It's 2 p.m. Eastern Daylight Savings Time, so we are going to go ahead and get started. First, what I'd like to do is just review a few logistics related to this webinar. To ensure the best audio experience, the conference has been placed in silent mode. However, if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A pod located on the lower right-hand side of your screen. This works like a chat. Today's webinar is being recorded, and the recording will be posted both to our online Adobe Connect webinar catalog as well as to our NASA Earthdata YouTube channel within a couple of days of completion. And what I'll do is I will send all registrants the links to these recordings. In addition, today's presentation files will be available for download at the end of the webinar. With respect to timing, today's webinar is 1 hour long. We've allocated 45 minutes to the presentations and live demonstrations, with an additional 15 minutes for the question and answer period. So once our speakers have finished with their presentations, what we'll do then is we'll transition to an optional final set of polling questions. And usually I'll give these just a couple of minutes or so, and then from there, we'll move directly to the Q&A period. Excuse me. One final note, depending upon how many questions we receive, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. for those of you who may wish to stay on the line. Okay, so during today's webinar, as you can see, we have two speakers. Our first speaker is Jessica Hausman, who is a data engineer at NASA's Physical Oceanography Distributed Active Archive Center, or PODAAC. She will spend the first half of today's webinar providing an introduction to both PODAAC and Drive as an alternative to FTP, as well as walk you through a live demonstration using Drive. Our second speaker today is Dr. Louis McGibney. He's a data scientist and engineer at PODAAC, and he will continue the second half of the webinar by walking participants through an introduction to PODAAC Pi and other web services, as well as to include a live demonstration on how to access ASCAT data within the Jupyter Notebook environment. With that, it is my pleasure to introduce today's first speaker, Jessica Hausman. Jessica?
Thanks, Jennifer. So as Jennifer stated, I'll be going through how to use Drive, which is basically the alternative to our FTP. Everyone is doing that. So in this presentation, I'll go over basically what PODAAC is, why the FTP is being deprecated, different ways you can access data at PODAAC other than Drive and web services. And then Louis will continue with the demo of PODAAC Pi and the different web services available at PODAAC. So for those of you who are not familiar with PODAAC, as Jennifer said, we are the Physical Oceanography Distributed Active Archive Center. So that's where the DAAC comes from. There are 12 DAACs in total, which are all managed under the Earth Observing System Data and Information System, which is ESDIS under NASA. That takes care of all the Earth system data and the infrastructure for that. The 12 DAACs are separated out by kind of discipline or science topic. And so PODAAC is the Physical Oceanography Data Archive, which means sea surface temperature, sea surface height, all the physics. And so that means like all the biology, all the chlorophyll is actually going to be located at the Ocean Biology DAAC. And you can see also there's a National Snow and Ice, which is NSIDC, and so on. So at PODAAC, we have, like I said, we have data sets for sea surface height, sea surface temperature, winds, gravity. We have data going back to 1978 with the first oceanographic NASA mission, which was CSAT. And we have continuing missions with TOPEX Poseidon, QuakeScat. The newest satellite they just launched was GRACE-FO. And our big one is going to be SWAT in 2021, which is going to be a subsurface height mission, along with the first inland hydrology mission as well. So the FTP deprecation. So NASA is deprecating anonymous FTP. This is across all of NASA, just not at PODAAC. And that's because there are multiple security problems with using anonymous FTP. However, at PODAAC, we do recognize that FTP is the most popular way our users access the data. And so that we realized that we needed other methods so that users can still access the data without too many hiccups once FTP is completely shut off. At PODAAC, we will be shutting our FTP off in June 2019. If you do get data from other DAACs, please check with them and see when their final shut-off date is, as we're all transitioning over and our schedules are slightly different. So there are other ways you can access data as of today. One is OpenDAAC. We do have an OpenDAAC at PODAAC. And there have already been other webinars on the technology of OpenDAAC and how it works, where you can see those two YouTubes. And you can always ask Jennifer as well where they're located if those links don't work for you. We also have a thread server. So OpenDAAC and threads, the great thing about those is that they let you subset the data. OpenDAAC works for swath and gridded data, whereas thread only works on gridded data. And you can also get aggregates, which means you can combine multiple files into a single file. And then there are the web services, which Lewis is going to go over later. So one big change with using Drive is that you need to use Earthdata login. So Earthdata login is the centralized mechanism for user registration and profile management across all of ESDIS and the DAACs. So once you create a profile, you will use that same username and login across all the DAACs and across all the ESDIS tools if you are prompted for it. So you don't have to worry about having multiple usernames and passwords across all the DAACs. One of the nice things about having a profile system is that now NASA can see how users are using the data, so they can better understand what data are being used and what the user needs are, so that we can, it'll help us with future development of our tools and services, and that they're being catered to our users. And also, if users elect to, they can receive notifications on the data sets they use, like if there's going to be a safe hold or an interruption of service, or if new versions of the data are going to be available. And you can use that link on the bottom there, and that'll take you to more information for the Earthdata login. And if you don't already have a profile, you can create one there. So Drive. Drive is something that we created to give you the best look and feel compared to FTP. So it is via HTTPS protocol. Since we are using HTTPS, it means that we can also use the technology called WebDev. WebDev is an extension of HTTP, and what's great about that is that it allows you remote access to our servers. Because we're just distributing data, you can only pull from it, but there are other places where WebDev can act as a push or a pull. But at PODAAC and at all the DAACs, it is only going to be a pull mechanism. So that means that you can either download data like you would with FTP, or the powerful thing about using WebDev with the remote mount is that you can actually have it look like there is another, basically, drive on your machine. As I said, it does require an Earthdata login. The structure has a very similar look and feel when it comes to the file directory system. Of course, command-wise, you are going to be using different commands if you tend to do scripts, or if you like to use the terminal command to grab your data. Drive is available at other DAACs, so once you understand how it works at PODAAC, it should be similar at the other DAACs. It's just you'll be logging into their Drive specifically. And you can also read up more about how it works on the other DAACs at the link at the bottom there. And for those of you who kind of like going at your own pace, these are going to be the links I'm going to be using for the demonstration. So we have the PODAAC portal, we have the Drive page, we have the help page. At the moment, you do need to be logged in to view the help page, and as you'll see later on, there are specific examples that we provide you that do use your own username and password. We are working on a way to make a more generic page, so then that way everyone can just see a generic page, and it won't have your specific username in there. We have a forum topic on Drive, so if you have questions about Drive or want to find out more information, you can always come to our forum. Everyone can view the forum, but if you want to post, you do need to log into Earthdata, and there'll be a link on the right side of the screen so you can log in. And then we also have recipes posted on the forum, so just little scripts, one-liner type terminal commands so that you can get to Drive. Okay, and next we will start the demo. And I'll just start sharing my screen. Okay, so hopefully everyone is seeing my web browser. It should be coming up any second. There we go. So what you should be seeing is the PODAAC homepage. So I gave you the direct link to get to Drive, but in case you don't remember, that's fine. The easy way to access all data at PODAAC is you can click on the Data Access tab, and here you'll see a direct link that will take you to Drive. So I'm going to go and cheat a little bit. I'm going to take you through and actually have to log in through Earthdata Drive. And the screen is just taking a little bit longer to refresh. And then I now have my, my username and also my password, which has gone through WebDev. So there are two passwords you actually have to use when you're using Drive. One is going to be when you go to the Earthdata Drive, you have your Earthdata login that you created. So you'll log into that. And then when you get this screen, you notice there's a different password. This is specifically for WebDev. And so this password is going to change with whatever DAAC drive you use. So you wouldn't use this one if you're, let's say you're using PODAAC drive. So if we click on Browse Files, this will actually take you to the HTTPS link. So you can see this is the HTTPS, and you can see that there is our directory system, and I have a tab already open to our FTP. So if you compare the two, so this is our FTP, we have it separated by discipline, and you can see on the HTTPS it is also separated by discipline. And then if you click on All Data, that'll give you a listing of the individual missions, and it works the same on FTP. So look and feel-wise, navigation-wise, it is exactly the same. We also have our help page, so you can get to that. If you go back to your original login page, there's a link to go to help. And so as I said before, the help page currently has your very specific user login, and that's why it's currently behind the login page. But we give information on how to mount via OS Mac, Windows, or Linux. And then there's also how you can get the data via curl, wget, or aria. These are all command line tools. So if you are more comfortable scripting and writing your own cron jobs to grab the data, these are probably the commands you would use rather than the FTP command. And then we have the forum. So you can see this is specifically for the Drive forum. And then if you want to post a topic within the Drive forum, as I said before, this is where you can log in. And so you can see we have multiple topics that involve Drive, and there is a specific one for the recipes. And so we have multiple recipes. One is how do you navigate, how do you get your username and password for WebDev, how to use wget, and also we've had some issues with people trying to get on with the Unix machines, and so this will provide you more help if you want to get Drive through a Unix machine. All right, so I'm going to run through an example and actually grab some data. So we're going to go with the wget one. So wget, as I said, is just a command line. So I already have an example here. You do need to be aware of how you're going to grab the data because, as you can see, this is wget. That's the command. I have my username. I have my password in there. And then there are all these flags. These flags help you recursively grab the data and also allows you to use wildcards. So if you want to use a wildcard, you need to have this -A and then basically your wildcard in quotes. So you can see this is the URL I'm using. So I'm saying anything past this folder, I want to grab all the data that are from October 1992. So we'll execute, and so now it's accessing the server, and now it's just grabbing all the individual files that are for October 1992. So this will just take another minute. So as the data are being downloaded, we can actually go to my folder that I created for this, and you can see that the data are being populated as we speak. So we have the data coming in. And then we can also just look at one really quick. So I don't know if you're familiar with Panoply. Panoply is this really handy NetCDF and HDF data viewer. And so this is one of the files I grabbed using wget. And so the data I grabbed was sea surface height anomalies or sea level anomalies. It's basically kind of like all the bumps and divots in the ocean. So I can create a plot, and you can see here you have, so this would be the Gulf Stream. You can see all the eddies coming off the Gulf Stream. You see the eddies coming off the Kuroshio. You see the Agulhas. And so this is what I would expect to see from the data. So there's also the powerful thing you can do, which is the remote server. So as I said, you need to go to the help and find out how specifically you would mount a remote server for your operating system. So for me, since I'm using a Mac, I go to Go, and there's a connect to server. And as I said before, we do have the directions. So the remote address is this one. It takes you straight to the files. So I will connect, put in my username. And as I said before, I need to use the WebDev password. Do not use your Earthdata login password because it will not work. So you can see I have more files in my directory where I grabbed the data from wget. I should now be able to see files. And so that is the remote server. And as you can see, this directory listing is just like it was here for the HTTPS. So I can now navigate the files as if it was on my machine. Do keep in mind, because it is a remote server, it will take a little bit of time for things to kind of cache and come in, but it's all there. You just got to wait a little bit for, probably just a few seconds. So now I have the mount. As Lewis is going to be doing a lot of Python examples, I figured I would show you something using a different language. And so there are a lot of oceanographers that use MATLAB. I'm going to show you a MATLAB example. So here I have, on a Mac, your remote servers are found in this volumes folder. You'll have to figure out exactly what it is if you're using another type of operating system. So we'll just evaluate it. So basically what I'm doing is I'm grabbing a file from my remote mounted drive, and I'm just reading in the latitude, longitude, and sea surface height, and I'm creating a plot. So here, as you see, as I showed in Panoply before, you can see the different eddies for the Gulf Stream, the eddies from the Kuroshio, and also the Agulhas. So visually, the data look the same. But I really want to know for sure. So what I'm going to do is compare one of the files that I downloaded using wget, read in the latitude, longitude, and sea surface height. And then what I'm going to do is do a difference, basically, of what I grabbed. So this is from the remote server. So that's the remote server on my drive right now. And then this is what I got from wget. So I'm just going to do a difference of the two. And since if I did a difference, and if the data are exactly the same, if I look for a minimum of the difference and a maximum for the difference, they should all come up as 0. So that means I have the exact same data, getting the same file 2 different ways. So hopefully this kind of helps give you an idea of how Drive works, the different ways you can use Drive within your code or just downloading the data. And now I'm going to turn it over to Lewis, who's going to talk about PODAAC Pi and web services.
Okay. Jessica, thank you very much. Thank you. We'll just quickly go back to the slides here. Perfect, perfect. Thank you, Jennifer. Okay, let's just go back to the very beginning of the webinar where we polled quickly for proficiency with Python, and we polled for proficiency with Jupyter Notebook environment. Let's start with the first question. It looks as if most people on the call are aware of at least what Python is, and a lot of people are using it to some extent, which is great. The development of PODAAC Pi at JPL's PODAAC was no coincidence. I think we're very familiarized with the fact that Python is becoming somewhat of the de facto language for scientific computing, and hence the reason why PODAAC Pi has taken off as, you know, a very intuitive, client-side, user-friendly toolkit for interacting with NASA JPL's PODAAC. So what we're going to cover in the latter part of today's webinar is, you know, what is PODAAC Pi in its essence, and what does it really cover, and where is it developed? We move on to, you know, who develops it and who owns it. We'll then look at user and developer level documentation. The toolkit has been developed with documentation and testing in mind from the beginning, and so I think that that's a very important part which the community online and anybody watching these webinars on YouTube or elsewhere will certainly appreciate. So we'll then move on to utilising PODAAC Pi within your own environment and how the packaging ecosystem works there. Those that have been using Python will realise that, of course, you can install Python source code. However, it's always very nice if you have some sort of packaged environment such as pip, the Python packaging manager, or something like Conda, which is certainly becoming more prevalent and certainly more widely used as Python grows itself as well. Then we'll kind of finish up here by looking at some examples of PODAAC Pi, which demonstrate data access patterns for interacting with PODAAC data other than FTP. So it's all the other services which enable you to do exactly the same as you previously were doing with FTP without FTP. Okay, so some prerequisites before we get on there, some justifications really again for the toolkit, that although web services are programming language agnostic, and what I mean by that is essentially the HTTP and HTTPS secure version of interacting with data services over the web. You don't need to, you can use essentially any language you want in order to interact, or more or less any language you want in order to interact with these data services. And although the web services are programming language agnostic by nature, not everyone knows the tooling. Jessica has introduced a number of command line clients, and the flags are different in each one, and you know, usually what you'll find is you have your own favorite and you get to know it, and that's fine. But again, maybe not everybody likes using the command line. You skip between operating systems, and some of the command lines can be different from others. So therefore, PODAAC Pi is a user-friendly programming toolkit which lowers the barriers to interacting with PODAAC web services. And what we mean by there is basically we're moving to automate the execution of repetitive tasks, such as data download, data subsetting, maybe granule downloads and granule searches, and the type of interactive data access patterns which require you to reuse the actual going and getting of data. So with that, let's take a look at what it is further and what it actually does. So we've mentioned that it's a Python toolkit for interacting with several of PODAAC's public-facing data web services. I'll go on to describe exactly what these are when I show you some of the code involved. Where is it developed? Well, we have a growing community over on GitHub. I made an effort to grow the toolkit in an open source organic fashion, and PODAAC in the URL there is now located under the NASA organization in GitHub under the PODAAC project, which is the project repository. If you were to navigate to that URL just now, you'll be able to essentially follow along with what I'll be demoing, what I'll be showing in due course. And who develops and owns it? Well, this one was very clear from the outset as well. I wanted the toolkit to be licensed in a permissive fashion such that you could pick it up and use it. Therefore, it's licensed under the Apache License Volume 2.0. And therefore, nobody owns this software. It's whoever's developing it is essentially in governance and stewardship of that code base. And without the community, there is no real code. Luckily, we've been growing the community in the GitHub repository and over in the NASA organization. And that will be the way that continues to grow. So let's take a look at where PODAAC lives, some documentation, and then we can get on to some examples. So I'm looking now to share my screen. Thank you. There we go. Browser. My web browser. There we go. Okay, perfect. So you can see here I'm over at the PODAAC repository on GitHub under the NASA organization. And what this is typically when you'll be browsing code on GitHub, what you'll see is any reasonable repository should have a README, which PODAAC does. You'll see these badges at the top. These are all hyperlinked. You can see that they've got badges for license, for documentation, which will go on, for stuff like code coverage and requirements, the health of the project. And you can also see that the PODAAC on the Conda platform has been downloaded more than 21,000 times. So we're getting some reasonable uptake on the toolkit, there's no doubt about that. But what does PODAAC offer? Well, the library provides Python interfaces for all of PODAAC's web services, everything from dataset metadata, dataset search, granule search, image generation. But some of the more interesting web services at PODAAC, such as the metadata compliance checking utilities, level 2 subsetting for regional subsetting capabilities, and of course, as Jessica had introduced today, the PODAAC Drive capabilities, which is of course the replacement for FTP, or one of the replacements for FTP. Additionally, we've been growing the capability of the toolkit outside even of PODAAC to other oceanography data sources, such as NASA's Ocean Color Web, where we have capability for file search and bulk data downloads via the HTTP. And again, what's important here is that PODAAC takes the pain out of coding from scratch the way that you interact with all of these services. What we've tried to do, and I'll show this in some of the examples, is make it so simple that one line of Python code would enable you to interact with more or less each one of these data services. So I talked in the table of contents about both the installation but as well as the availability of PODAAC within the Python ecosystem and the packaging ecosystem. So using pip, which is the Python package manager, which you most likely familiarized, I would imagine, with using Python. PODAAC is as simple to install as these three keywords. Pip install PODAAC. Again, in the Anaconda environment, you can essentially install you can install PODAAC through Conda as a package. If you wanted to download the code as source and maybe run some examples locally, which is exactly what we're going to do today, or maybe there's some feature that you wanted to add or a bug or something that you wanted to investigate, you can clone the code directly from the PODAAC project under the NASA GitHub repository, and then you can set up, install the code yourself. Some of the other interesting parts of the README is links to the Quick Start. It's in the examples directory. I'll be showing this in due course. We have a test suite, so every single function within every single Python file in PODAAC is tested, and we verify these tests. I'll go on in 2 seconds to show you where our documentation links are. You can see one here, hyperlink. We have our host of documentation on Read the Docs, which is kept up to date with how the code is being developed. But again, if you have the code locally and you wish to build the documentation locally, if you didn't have internet access, then you can also build the code locally. Finally, what we have is some links to our community support and development on the issue tracker via GitHub, some information on the license, and some copyright and export classification, which was mandatory based upon the open sourcing of this code from NASA JPL here in Pasadena, California. Okay, so as I'd mentioned, browsing back up the README, if we were to click on the documentation link or the link further down in the README, we end up at the online version of our documentation. And it's important for me to distinguish here the difference between user level and developer level documentation. So user level documentation will essentially be an introduction to what the toolkit is, describing everything more or less that's on that README and a whole bunch more. However, the user documentation goes further than that to provide code examples. And for those that aren't very familiarized with Python, don't worry. The pattern for utilizing the code has been kept very clear and concise, and it's well documented with a lot of text as well. So this is your user level documentation which you can browse through. However, what we also have is our developer level documentation, and as I've mentioned, every function, every class and every function within the toolkit is documented in such a fashion that your parameters are explicit, the default values for parameters are explicit, every return value that you should get is explicit, and typically everything's documented, nice and concisely, nice clearly, for you to be able to pick this toolkit up and use it as you wish. So you can see on the left-hand side as well, we have documentation links through to various portions of the toolkit APIs. So let's go on to think about some examples. I've mentioned previously that within the PODAAC repository, we have an examples directory, and that's where I am just now. Over time, we've been starting to grow some of the examples. For example, we presented to the Cygnus Science Team meeting. We have an introductory getting started tutorial. We also have some tutorials on regional climate modeling, some regional studies, and how PODAAC is playing a role in those types of studies. But from the command line, if you were to wish to run some of these studies, for some of these examples, you would need to change into the examples directory, and then you'd be required to execute the Jupyter Notebook task. And before we go on too much further, I just want to very quickly explain a bit about what the Jupyter Notebooks are. It's important for me to state that Jupyter Notebooks and the notebook environment is not a prerequisite to using PODAAC. PODAAC is a pure Python toolkit. Jupyter Notebooks are being used as a data exploration mechanism here, merely for the purposes of demonstration. So if we go over to the Jupyter homepage in jupyter.org, there's a brief project description, but one of the popular portions of the Jupyter project which is used is the Jupyter Notebook. And it's described as being an open source web application that allows you to create and share documents that contain live code, equations, visualizations, and narrative text. Uses include data cleaning and transformation, numerical simulation, statistical modeling, data visualization, machine learning, and much more. And we can include within that much more essentially interacting with data services at NASA JPL's PODAAC. So let me head over to my terminal. You can see in my terminal now that I'm within the examples directory under user local PODAAC PI examples on my local machine, and I'm merely going to execute Jupyter Notebook. What this does is it starts up a notebook server and will essentially enable me to have a look at everything that's been all of the examples that were available through the GitHub repository. I'm just cleaning up a bit here, some examples, so apologies about that. But the example we'll be using today is using PODAAC PI to interact with PODAAC Drive. So let me click on that notebook. And what this does is it starts a kernel on the machine, on the server, which essentially enables me to execute Python code in a cell-by-cell fashion. So each cell is a unit of execution, and we execute them by clicking on the run icon up the top here. So typically how I start my notebooks is just by a license. But let's concentrate on cell number 2 here, and a description of what the example is going to be. We're stating that in this example, we replicate the following workflow. We're defining a temporal and spatial characteristics of some phenomenon, of a given event in this case, which is Hurricane Florence, which is a very recent major hurricane to impact the southeastern United States. We search for all available whole orbit granules for that event and download them from PODAAC Drive to the local machine. We view the files in the Panoply data viewer, which Jessica utilized earlier on, but more information from that can be found under the following hyperlink. We then take it a step further and streamline the above data acquisition task, data discovery and acquisition task, using PODAAC's level 2 subsetting software to download a regional subset of the event at a given space and time. So we're downloading the whole orbit, and then we're doing the regional subset. Finally, we view the subsetted granule again in Panoply. As Jennifer had kindly mentioned at the beginning of the webinar today, we've chosen the METOP ASCAT Level 2 Ocean surface wind vectors optimized for coastal ocean collection as our subject matter. This dataset contains operational near real-time Level 2 coastal ocean surface wind vector retrievals from the ASCAT instrument on the METOP A platform at 12.5 kilometer sampling resolution. And it's to say, there's just a quick note here that the effective resolution is 25 kilometers. There's some more information here on the dataset itself, which it should note here that is a non-NASA dataset as well. But more information on this dataset, along with a lot of information about all of the datasets, collections, platforms, and sensors that PODAAC serves data for, can be found at this hyperlink. And there's project pages, there's platform pages for all of these datasets. So very quickly, just before we get on to executing some Python code, this is a kind of a graphic really of what the ASCAT scatterometer coverage looks like. And you can compare this maybe to some of the data you see in Panoply later, and you'll see that there's some discrepancy, but Panoply does its best job at representing this data accurately. Okay, folks, let's go on then to executing our notebook. So first, let's import the libraries that we actually require. You can see here that we're importing PODAAC, your utilities, and our functionality from Drive. We then create instances of these classes that we're going to use. It's important for me to very quickly state that this file, PODAAC.ini, initialization logic, contains the exact same data that Jessica referred to earlier on, which is your username, your Earthdata login username, and the encrypted password. So that information should be contained in that file. This is all documented in the online documentation as well. So once we've imported our functionality and created an instance of the functionalities, let's discover PODAAC wind data relating to our subject matter, Hurricane Florence. Using specific parameters to confine the discovery space, we opt for the full metadata record in atom format. You can see here we're passing in our temporal parameters as well as our spatial parameters. So let's execute that query. Again, what you can see here, this is one line of Python code with parameters, okay, to do a full dataset search. We've got a full XML response here, which is rather lengthy. There's a lot of metadata here. What provided in this notebook is that because we provided the full response, we can actually extract the PODAAC drive URLs for all the granules contained within this data set. So let's just cut it down immediately. This link here, if you can think back to the links that Jessica was showing, this is exactly where we want to be. It's directly getting us to the METOP-A platform, and we're looking for the coastal optimized ASCAT data there. So we could essentially navigate through to that hyperlink and we'd be able to manually browse everything that was there. But next, let's search for granules of interest relating to the above discovery operation. Let's execute a search for specific granules from the following data set based upon the same spatial and temporal constraints. You can see in the IPython notebook when you've got an asterisk running here, that means that this cell is executing. We can see here very quickly what we've done is we're just looking for the part of that XML response which tells us how many results we have. So we found 6 granules. Well, let's actually print the granule names themselves. This is similar to what you would have seen in Jessica's machine earlier on, not in terms of the file name, but just in terms of the fact that we've got netcdf granules which we're aware of. We can now we need to reproduce the drive URLs for the above granules. Again, this is one line of Python code. We have our drive URLs. These are compressed, they're hyperlinks to the compressed versions of these granules. And essentially, what we're trying to do here is download the granules to the local machine. So let's go ahead and do that. It's important to mention that once this is working away, we've defined the local path as the path within the notebook server. So if we go back to the notebook server, you can see that I deleted those granules originally. They're now back home. Okay. What we do here essentially is open all of these files within Panoply. Again, it was the data viewer that we'd mentioned earlier on, an excellent data viewer for netcdf, HDF, and GRIB files, which is happening here. You can see that of those 6 granules, I've got 1, 2, 3, 4, 5, and 6. Let's just check one of the granules out, remembering these are full orbit granules, full swath. You can see here that we have the full orbit. And let's just go ahead and focus into our temporal area. You can see that this is the Hurricane Florence strengthening of the southeastern coast of the United States, with Florida down in the lower cell there. Okay, this is great, but we can really take this a step further. And we take it a step further by subsetting, utilizing the level 2 subsetting capability at PODAAC. So essentially what we do here is we import the level 2 subsetter class from the Python toolkit from PODAAC. We construct an instance as before. We then pass in a particular granule ID that we're interested in, which we obtained above. And we define our variables along with the temporal, the spatial constraints. We pass in essentially the 4 variables which we're interested in: latitude, longitude, time, and wind speed. Let's go ahead and execute that. One of the nice things about the L2SS execution as well is that you can provide your email address, and the L2SS service will email you when your granules are available if it's a large data request. So we go ahead and execute that. You can see that it's working away. What it's done now here is we have our subsetted granule available, and we can go and check out the wind speed. We can see here that rather than the full orbit pass, now all we have is our regional subset. And again, you can see the wind speed, the concentration of strengthening of the southeastern United States. So let's go back very quickly and we'll conclude the webinar, this portion of the webinar. But just want to leave everybody here with a final comment and some food for thought. That if you were to write the above Python script from scratch without using PODAAC, you'd have to write, around probably more than 400 or so lines of Python code. Less the print statements, we've achieved it in less than 30 lines of code. There's been some data massaging, but that's for the purposes of the presentation today. So we've achieved this in less than 30 lines of code. What is more, The code we have used has been tested by many users, as well as by our rich unit testing suite. I had mentioned that every function in PODAAC Pi has an accompanying test. And with that, I think we'll probably pass it back over to Jennifer, our host, and say thank you very much. Please report any issues with the above notebook over at the PODAAC Pi repository on GitHub. Thank you.
Okay, thank you, Lewis. Thanks, everybody. At this point, what we'll do is we'll transition to a final set of polling questions, and we'll give these questions about 3 or 4 minutes or so, because we do have a couple of questions that require short answer responses. And then from there, we'll move directly to the Q&A period. So if you have questions at that point, you'll type them into the Q&A pod, and our speakers will answer your questions. So let's give these just a couple of minutes or so, and then we'll transition to the Q&A. All right, thanks, everybody. This is very useful feedback, everybody. We're going to give these questions just another minute or so, and then from there we'll transition to the Q&A. Okay, everybody, at this point we're going to transition to the Q&A portion of today's webinar. Before we do that, I want to draw your attention to the lower right-hand corner of your screen. There you will find today's slide deck available for download, both as a PowerPoint as well as PDF, and then also today's agenda. So if you were to click on any one of those files, you should be prompted with an option to download that file. All right, and with that, earlier on there was a comment, and I wondered if one of you could say a few words about the capabilities within Jupyter Notebook, and a little bit more about what that is and how that can be utilized.
Yes, I'll be more than happy to take that one, Jennifer. So,
okay, thank you.
Jupyter Notebooks were developed with to address the requirement, I think, for interactivity within the way that people develop code. And if you think about a peer-to-peer, maybe 2 or more people sitting writing code together, discussing it, a lot of the way that science is done is by the analysis and the generation of results and the review of results. hypotheses are proven by the review of those results. And I think that sharing these results was an issue that I think we've all within the scientific community been not so much struggling with, but I think it's something that journals are asking people to reproduce and share, how you got to where you got to. Jupyter Notebook is essentially an environment which enables people to, in a remote fashion, interactively discover and explore science essentially through the code. So it's changing the way that people develop code. They've been working a lot on accommodating many languages, everything from C through to stuff like Python, more of some of the modern languages, and really that's the way that entire project has been going. One of the things that I should mention in it, though, that it's got excellent capabilities for getting within 1 or 2 cells from maybe a data analysis through to visualization. And because these the cell execution can essentially, you can skip forward and back, you can move cells around just as you would do a presentation. It's an excellent mechanism for essentially doing that interactivity, achieving the interactivity portion of the science that you're trying to do. Hopefully that's explained a bit about it. Again, the Jupyter, you'll be very happy to know as well, is packaged very well within the Python ecosystem. Can be downloaded either through, well, actually the same 2 channels that PODAAC Pi, it's pip package manager, as well as Conda environment. And I believe that there's maybe even operating system specific packages, maybe Brew for Mac. You should probably be able to install Jupyter through Brew, and maybe apt-get or something else for Linux and various other environments. If not, then you just head over to jupyter.com and you can download the package binaries from the website.
Okay, well, thank you very much, Louis. Does anybody have any questions? Remember, if you have a question, please enter that into the Q&A pod, and you'll find that located on the right-hand side of your screen, and this works like a chat. Any questions? Okay, well then really quickly, while we're trying to figure out if there are any questions here, to the left you'll see some information regarding where we house our data discovery and data access webinars. And so through that YouTube channel, there are close to 100 data discovery and access webinars, some of which go through some step-by-step tutorials for using R and Python and processing NASA Earth science data, not specifically within physical oceanography, but certainly, okay, that's a good question here, but certainly for example, for land processes, data products, or other of our data holdings. All right, so we do have a question. What is Drive based on? Is it Google Drive?
So Drive is kind of a generic term. So Google Drive calls itself Google Drive because it's kind of like a file system. So Drive is just a file system. That's why we use Drive, because it is our file system that we use on WebDev. So WebDev is using an extension of the HTTP protocol. So WebDev is actually a type of protocol. It has no relation to Google Drive. It's just that we are both using the HTTP protocol. So that's the only commonality in there. There's no Google software involved within it at all. You can implement it similar to OpenDAAC, as I showed in my MATLAB example. Excuse me. If you remote link to the server, so if you mount the remote server onto your own machine, you can navigate Drive as your own file system on an external drive. So you can still do command line execution like you would with OpenDAAC. You can't quite do this similar, like with OpenDAAC, you would use a URL, and then you would put your search terms in the URL with OpenDAAC. You wouldn't do that with Drive. Instead, what you would do is the web services that Louis demonstrated. So I hope that answered your question.
Okay, thanks, Jessica. You actually answered the second part to that particular participant's question. So the next question is, the utilities and Drive API document, and then the link is provided, on your PODAAC Pi, read the docs, are empty. Are you going to update them?
Oh, so, I didn't realize they were. I certainly will make sure that they are. I certainly will make sure they are. Okay, so what I would like to say about that as well, sometimes essentially the documentation itself can be generated locally again as well. If you have some issues with that, this is a perfect example of why maybe things that I haven't caught, if there's more people using software, things that I or others haven't caught, it's an excellent example to go over and maybe log an issue and make that explicit. I've taken a note for it just now, and I'll make sure to fix that. You can still navigate to the Python code itself and look at the inline functions, but of course that's not where the documentation should be. I'll make sure that gets fixed. Thank you very much for the question.
Okay, thank you, Louis. So there's a couple additional questions as well here. The first is, again, a follow-on to a couple of the questions that were asked. I guess I'm wondering if this is proprietary to NASA or if another institution can implement their own server.
So like I said, this uses WebDev, and so WebDev is its own freely open source software, I believe. So Drive itself, that we're using through ESDIS, that software itself you won't be able to get only because of the way it has to connect to the servers. But anyone can actually use WebDev to open the remote link to their servers themselves. So it's the specific execution of WebDev to our different DAACs is specific to the DAAC. But if you wanted to do this like at your own home institution and open your own data center or extend capabilities of your own data center, you could look into using WebDev as long as your data is available on HTTP.
Okay, great. Thank you so much, Jessica. We do have another question. The question is, can the new data service be accessed by Xarray?
Okay, so you can, of course, you can use Xarray within. I'm just trying to clarify both parts of what I'm thinking the question maybe refers to. The new Xarray is not compatible currently with PODAAC Drive through the Xarray APIs. It's not the kind of subsetting analysis portion of it. If Xarray has a capability to grab files, remote files, from an HTTP available URI, then you could potentially use whatever you get from Drive within your Xarray execution environment. I just want to make sure that we're not confusing utilizing Xarray within Jupyter Notebooks with what Drive is capable of doing. As we've mentioned here, Drive is essentially a virtualized file system, a virtual file system which we interact with over the WebDAV extension of HTTP. And that's essentially all that service is. It's a direct replacement for FTP. And once you have your data locally, then you could read it in. But I don't think there's the capability just now for native object serialization within Xarray directly from PODAAC Drive. Or that's certainly not something that we've been working directly on integration with. But we'll take a note on that.
Okay, thank you, Louis. And for this participant, does this answer your question? If not, could you provide further information within the Q&A pod? All right, let's see here if we've got any additional questions. Does anybody have any additional questions? Okay, so if there are no further questions, what we'll do is we will leave the virtual meeting space open an additional 10 minutes. I would ask that our speakers please stay within the virtual space until 3:10. So if you think of something, please feel free to enter that into the Q&A pod. I can certainly forward that along to our speakers, and they'll be able to address your inquiry offline with you. And then we will log off from the audio component. And then for those of you who are able to participate today, and then those who maybe registered but were unable to attend, I will have the recording links, both the direct link and also the YouTube link, sent out to everybody by Friday. And through the direct link, the file sharing pod, you'll be able to, that's a persistent feature, so you'll still be able to download the files. And that's true for any of our recordings. And you'll find those direct links at the tinyurl.com Earthdata webinar to the left there. You can, kind of scroll through. We've been holding these since 2013. And certainly email me with any questions, and I can put you in contact with our speakers. All right, so with that, I'm just checking one more time to see whether or not there are additional questions. It doesn't look like it. I'd like to thank our speakers and thank all of you for participating today. And, well, we will just check another time. No further questions. At this point, we'll log off from the audio component, and I hope to see you perhaps at an upcoming webinar. All right, well, thanks, everybody. And speakers, if you could just stay in the virtual space till 3:10, that would be great. And thank you, participants. All right, bye-bye now.